So implicit differentiation day 2, kind of like your 3.1 summary. We want to be able to work examples that now require all of your rules for differentiation, from product to quotient to chain, power rule, all of those items, while still utilizing the idea of implicit differentiation. So these are straight out of the textbook, okay? And at this point, we want to be able to take the first derivative and the second. And so we're just going to do a couple of examples that I think are good representations of the level of difficulty that you're going to see. So the first example we're going to do is number 5 in your book. This is from section 3.1. So derivative of the first times the second plus the derivative of the second times the first. And this will give me this portion. The derivative of the first times the second plus the derivative of the second times the first. Okay, and so 2xy plus x squared. Now I'm going to do dy dx on this example, and then notice I used y prime here. Y prime and dy dx are interchangeable. And so check my math, because it is very easy to lose something when you're doing this. And remember, y prime and dy dx are interchangeable. So yes, I changed it. Okay, so now I'm going to keep the dy dx terms on this side. Okay. And derivative of the first times the second. I'm just going to talk myself through it again. Derivative of the second times the first. So that's correct. And then the derivative of the first times the second plus the derivative of the second times the first. Done. And then the derivative of x is 1. Derivative of 3 is 0. Moving the 1 over. Now moving the 2xy. Now moving the 3y. Now I want to factor out the dy dx. And now I want to divide out this. One of the most important things to note is I try showing all my steps, but if I make an error, please point that out tomorrow in class, because sometimes I look over it, I still miss the error. And it is very easy to miswrite or to forget an exponent or to drop a minus sign. And so those are errors that I'm hoping you're trying these at the same time maybe, and that you can point them out if I've screwed it up. Okay, so that would give me my answer, because number 5 just says find dy dx. It doesn't say to evaluate, it doesn't say to do anything, it just says to find dy dx, okay? So we're going to do number 8 next. I would suggest possibly pausing the tape here and trying this one on your own. I'm just going to go ahead and work through it. And again, pause, and then you can see how my work follows along with your work. So the derivative of the left. So on the right, I need quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And now I need to do some math. X plus x dy dx minus y dy dx minus, I'm going to do this in 2 steps and hopefully eliminate an error. I'm bound to have an error here. Now, that minus sign that's there, I'm going to distribute that to everything inside it. So minus x, so I'm going to have negative 2y's, so minus y minus another y is 2y's. A plus x dy dx and a plus So plus 2x dy dx. And a minus makes that a plus, and a minus goes away. Okay. And that's everything, I believe. Okay. All over. And now I need to rearrange and solve. And I'm going to just double check there. So x dy dx minus y dy dx minus, and this would have been an x. I should not have changed that plus sign. I messed myself up. So I'm just going to rewrite what I had here. X plus y minus x dy dx minus y dy dx. I'm just doing this for my own sanity. And it would have been minus a negative, which is a plus, so that cancels, and the y minus y is negative 2y, and the x plus x gives me 2x dy dx, and the x cancels the x. Okay. I'm confident that I didn't make an error yet, although I shouldn't be. Here we go. X minus y, quantity squared, negative 2y plus 2x dy dx. And now I'm not going to FOIL this out or distribute it out or anything like that. I'm just going to leave it like this. And I'm almost completely done. If I had reduced it a step earlier, I would be done. So here we go. And I'm going to call that done. Okay, so on this one, I didn't have chain rule really. The chain rule was 1 here, 2x and then dx dx. So the chain rule there gave me 1, but because y was to the first power, there's really no additional component there that I had to worry about. So that's number 8. All right, let's take a look at number 10. And number 10 says, my bad, number 11. Is a tangent cubed. And so I like this one because it's got a couple of things. It's got a power here with a product. You're going to have a chain rule because you're going to have an inside and an inside. And then we have a power rule with a tangent function. So we have lots of things we have to take the derivative of. So go ahead and pause now, and I want you to try, and I want you to then see how yours compares to mine. So I'm going to ddx this. Okay, so pause now. And I'm going to keep working. So 3 tangent squared of x y squared plus y times the derivative of tangent, which is secant squared of that thing, times the derivative of the inside thing, which is product property. So y squared derivative first times the second plus the derivative of the second times the first plus dy dx equals 1. The derivative of x is there. So, okay. So all of this, which I'm multiplying by, I'm going to throw over to the other side. By dividing. So this side now is just y squared plus 2xy dy dx plus dy dx is equal to 1 over notice that the inside didn't change. I know I'm writing, not talking, but notice that the inside did not change on these two functions. It's exactly the same. That's all on the bottom. And now I want to subtract a y squared. And then I want to factor out the dy dx. Oh, my bad. I want to show you that step. So I'm going to get 2xy plus 1 is equal to 1 over 3. This is going to look super ugly, and it's okay. Oh, xy squared. Make sure I copy the problem down. And again, when you're doing your work, if yours is different than mine, be sure to ask tomorrow in class where I got anything from. Because if I miss something in my haste here, I want you to point that out to me. Minus y squared. And now my final step is going to be to divide both sides by 2xy plus 1. And I'm going to go ahead and take these pieces right here. No, it's not going to let me. Let's see if it'll let me group those. And then I want to copy that. Let's see if it'll let me do it without having to write the whole thing again. And then, so my final answer. Let's see if it'll let me do it. There's the numerator all over the bottom. And that's my final answer. Okay? So on day 1 in class, all we did was we practiced evaluating. So once you got it to something that looked like this, or even like this, you could have evaluated. You just plugged in x and y. Well, today, we're going to take it a step further because not only are you going to have to find the first derivative, but you're also going to have to find the second derivative. Okay? The evaluation part comes after you can actually solve. So this is the last one we're going to do today. And this one, I believe the directions say to find the second derivative. So on number 18, I'm actually looking for the second derivative of y with respect to x. So in order to get here, I first need dy dx. So the derivative of the first times the second plus the derivative of the second, which is going to be negative sine y dy dx, derivative at the inside, is equal to dy dx. And so I want to do some algebra, and so I get cosine y is equal to dy dx minus plus x sine y dy dx. So I'm going to move this over to the other side, so I add it because a minus would be a plus. And now I want to factor out a dy dx from both of these terms. So if we're just looking at general patterns here, the idea from Algebra 1 is still a completely valid idea. In order to solve for a variable, you have to isolate it. Only in this case, the variable that we're solving for is again, it's a variable in terms of variables, okay? So it just doesn't look as pretty as Algebra 1, but we can still isolate it and set it equal to something. So my first derivative, dy dx, is equal to cosine y over 1 plus x sine y. And that would be great if I were done. Unfortunately, I'm barely halfway. And the reason is, remember, I'm looking for the second derivative of y with respect to x. So that means I need to prime this whole thing. So the second derivative of y with respect to x is equal to, now I need to split this up. So f prime would be negative sine y dy dx, and g prime would be equal to the derivative of the first times the second plus the derivative of the second, colons, so we go. Now I'm going to have the dy dx there because anytime I take the derivative with a y in it, I'm going to have the derivative of y with respect to x component. So this is quotient rule, so I'm going to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, so now in order to isolate my dy dx thing, I need to pull out some stuff. I need to distribute this. I need to distribute this and then the minus sign. So I'm going to do that. So I'm going to start over here because I'm going to need that space. So I'm going to get negative sine y dy dx minus x sine squared y dy dx. And then I'm going to get minus cosine y sine y minus x cosine squared dy dx. Oh, this is going to be so pretty. You don't know it yet, but it's pretty awesome. Actually, I see something. And that's all going to be over okay. And so, assuming I didn't blow this, minus, and then a minus, oh, Miss Collins, cosine squared y, I did drop my y. Okay. So, okay, so here's what I'm going to do, because I like it. I like it a lot. I'm going to go ahead, and I'm going to regroup some stuff. At this point, if you didn't want to regroup anything, you could simply go up and plug in this, cosine y plus over 1 plus x sine y, everywhere you see a dy dx. You could just plug that in. But I think that it's important to note that this and this, if I group those together, and I factor this out, I get this. Oh, minus, my bad. Which, if I'm not mistaken, that's 1. So it starts to look a lot prettier. And now I just want to plug in my dy dx, which is cosine y over 1 plus x sine y. So dy dx is equal to cosine y over 1 plus x sine y. And now wherever you see a dy dx, you just want to plug that in. So remember, the second derivative of y with respect to x is what we were looking for. So negative x times cosine y over 1 plus x sine y. And for the record, I would not make you do more simplification than getting it back to checking your first derivative and then your second derivative, okay? Upon evaluating, if you knew the point, you could easily simplify this. There's no doubt you can all handle that. And then that's all over sine y. Miss Collins, that's a sine y. I hope some of you are catching these little errors. I write very quickly and I don't pay too much attention. So please pay attention for me. Squared. Okay? And I would go ahead and stop right here. because I'm hoping there would be a point I could evaluate at. I'm not going to make you worry about the common denominator here. That's just going to look super ugly. And so we'll just leave it at this, okay? But theoretically, you could simplify and get rid of the 1 plus sine x, or 1 plus x sine y from the end. But here's what I want you to do. Since the level that you're going to be expected to adhere to is out of your book, I want you to try numbers 3, 6, 7, 9, 10, and 13, 15, 17. Notice they're all odd with the exception of 2. And partly because I did 5 and 11. Okay, so I want you to try the other versions. All right, good luck.